Okay, there's some beginning or preliminary information we need to talk about first in order to use this method. If 4x equals 0, okay, then what must x have to equal? X would have to be 0. How do we know that? Yeah, because anything times 0 equals 0, right? So 4 clearly isn't 0. That means x would have to be, right? So if x times negative 5 equals 0, then x would have to be what? 0. Same reason, right? In order to get a product of 0, you've got to have one factor that's 0, yes? Okay. So let's expand that a little bit. If x times 3x minus 5 equals 0, then x is 0. Here, let's take out the 3 a minute. That'll make it easier. Then x could be 0, but could x also be 5? Because if x is 5, wouldn't it make this 0? Yes? Well, it could be 0, but what if it's 5, then this would be 0, which still would make this true, right? Okay. The reason we're looking at this is we're going to be using the zero product property. So it's a concept that says if you multiply two factors and get a product of 0, then one of the factors must be 0. That's the only way we can multiply two things and get 0. One or the other has to equal 0. Yes? So this is called the zero product property. Which says for all real numbers A and B. So A and B could be any real number. If A times B equals 0, then either A equals 0 or B equals 0. Either one would make that equation true. The way that we're able to use this is when we factor, most of the time we get two binomials, right? So we should be able to say if x plus 3 times x plus 2 equals 0, then either x plus 3 should equal 0 or x plus 2 should equal 0, right? Because those binomials are being multiplied to give us 0. So if we're getting a product of 0, one of the binomials should equal 0. Yes? So what that means, if I do this separately, so If x plus 3 equals 0, then what would make that true? X could be, what could I add to 3 and get 0? Negative 3. So x would equal negative 3. And if I were to solve that by subtracting 3 from both sides, I would get negative 3. So if I do negative 3 plus 3, this is 0, right? Which means that would be 0, and anything multiplied by 0 is 0. So negative 3 would make this true. With the other one, what would make this equal to 0? If I subtract 2, negative 2 would make that binomial 0. Now I know some of you are looking up here going, yeah, but if I plug negative 2 in, this is 0, but that's 1. Well, what is 1 times 0? 0. So negative 2 makes it true. Just like if I plug negative 3 in, here I get 0, here I get negative 1, but 0 times negative 1 is 0, so it's true. Either of those numbers would make that true, okay? So this is how we're going to use our factoring to find the solutions of a quadratic, all right? So the next thing you're going to write down is using the zero product property. In the first section of your homework, they're going to give you the binomials. You don't have to factor. But we are going to apply the property to find out what our variables should equal, okay? So the first step is set each binomial equal to 0. And I generally do one here and one there, separated by or, okay? So x plus 7 equals 0, or x minus 4 equals 0. Subtract 7, so x would be negative 7, or positive 4. Now think back to what our solutions actually represent. They represent where a parabola crosses the x-axis. Okay? If I were to FOIL this out, b would not be 0, right? I'd get a number for the middle term. Okay? Well, remember I said b messes everything up. When there's no b, our parabola is centered on the y-axis. That's why our solutions would be 4 and negative 4, or 8 and negative 8, or 1 and negative 1. B causes a horizontal shift. So the reason these numbers are not the same is because it shifted horizontally. It's no longer centered on the y-axis. So this particular parabola would cross the x-axis at negative 7 and positive 4. Okay? It's just not, it's off-center. All right? So it is okay to get two numbers that are not opposites of each other. And you do want to be aware, you will not always have a positive and a negative. You might have two positives or two negatives. It means your parabola has just moved that far to the left or that far to the right. Okay? But let's look at another, because some of you I know might be looking at this going, oh, well once I get those factors, my numbers are just the opposites. That's true if there's no coefficient. But if we factor and get something that looks like this, okay, you do have to solve. So starting with this, we would set each binomial equal to 0. And you don't have to put the parentheses in. I probably shouldn't have done that, but to solve for y in this case, I would add 5. So I'd get 3y equals 5, but I'm not done because I have to divide out that coefficient. And the nice thing is we're going to leave this as an improper fraction. So our solution here is 5/3. Over here, this one doesn't have a coefficient, so if you're looking at that thinking, oh, that's just -2, you are correct. That one is just -2 because there's no number to divide out. So if I subtracted 2, y would equal -2. So my two solutions would be there. So the only thing new that you're learning right now is how to apply the zero product property to the factors that we get. We are going to do a couple examples from start to finish so that you get used to doing these and finishing up with the zero product properties. Okay, so now we are actually solving by factoring. And that's, if you're looking at the videos, that's going to be on part 2.